press the bell icon on the YouTube app and never miss another update.
Okay, hello students. In the last class we discussed a few questions with regard to hydrogen. Let us move on to the remaining questions with reference to the hydrogen. The next question is, what is the volume of 20 volume H2O2 required to completely react with 500 ml of 0.02 molar acidified KMnO4 solution? Okay, so they have given the volume of both the solutions, and then one of the molarity has been given. We have to find out the that is the molarity as well as the volume strength of 20 volume H2O2. Okay, so here we are having the relationship that is normality of KMnO4 is equal to molarity of KMnO4 into n factor. Okay, so molarity of KMnO4 as it has been given in the problem, it is 0.02 molar into n factor is 5. So because whenever this KMnO4 react with hydrogen peroxide, KMnO4 will be converted into permanganate, will be converted into manganese. Then the oxidation number changes from +7 to +2. So there is a reduction of 5 units. So that is nothing but the n factor. So this will come around 0.1 normal. Okay. So next from this we can calculate. So we are having the relationship that is normality volume of KMnO4 is equal to normality volume of hydrogen peroxide. Okay, so we have to calculate the volume of 20 volume H2O2. So then volume of H2O2 is equal to normality volume of KMnO4 divided by, so normality of H2O2. So we don't know the normality of H2O2. For that we are having one relationship there. So that is nothing but volume strength is equal to normality into 5.6. So what is the volume? That is, we want normality. Normality is equal to volume strength divided by 5.6. So what is the volume they have given in the problem? That is nothing but 20. Okay, so 20 divided by 5.6. So that will come around 0.02. So put that value here. So normality of KMnO4 as it has been given in the problem, that is 0.02 into volume, that is nothing but 500. So sorry, this is 0.1 into 500 divided by, so this is 0.02. So that will come around 14 ml. So this is the answer. Option 1 is the answer for this question. Okay, understood this question? So if they given the normality and molarity, then you have to find out like this. So understood this n factor, how to find out? That is number of reduction unit in case of oxidizing agent, and then NF in case of oxidizing agent is number of oxidation units. Okay, so move on to the next one. Okay, so under the same conditions of pressure and temperature, which property is the same for hydrogen and deuterium? Options are rate of reaction with other substances, average kinetic energy per mole, most probable velocity, maximum density. So the answer is the option 2, average kinetic energy per molecule. Average kinetic energy per molecule. You know that this average kinetic energy is nothing but 3/2 RT, right? 3/2 RT. So it is actually directly proportional to the temperature. So it varies only with the temperature. So the answer is second one, average kinetic energy per mole. So next one. Next question. H2O2 cannot be formed by which of the following reaction? Okay, so we discussed all these reactions in the preparations of hydrogen peroxide. That is first one, electrolysis of 50% sulfuric acid. That yes, it will produce what? Hydrogen peroxide. So hydrolysis of that is H2SO4, that also produce the hydrogen peroxide, because both of them are having the peroxide. Similarly, action of phosphoric acid on barium peroxide also produces what? Hydrogen peroxide. The last one, that is nothing but action of H2O on MnO2. Action of H2O on MnO2 will not produce what? Peroxide, because this MnO2 do not contain any peroxide linkage. It is manganese dioxide. Whereas all other barium peroxide and peroxides of sulfuric acid, they are H2SO5 and H2SO4. Both are nothing but the peroxides of what? The sulfuric acid. As they are having the peroxide group, they will form hydrogen peroxide. But MnO2 do not contain any peroxide, that's why it will not form. So the answer is action of H2O on MnO2 will not produce H2O2. Next question. Yes, the hydride ion H minus is a stronger base than its hydroxide ion OH minus. Which of the following reactions will occur if sodium hydride is dissolved in water? Okay, so sodium hydride is dissolved in water means, we discussed this one also in the properties. So sodium hydride means NaH plus water. What it will give? It will form into NaOH with the liberation of hydrogen gas. With the liberation of hydrogen gas. So where it is actually? So if you go for the ionic form, that is the option number 2 is the answer for this one. H minus, that is nothing but ionic form. If you take, it is H minus plus water means you can have water only liquid. So it will form into OH minus plus hydrogen gas. So this is the answer for that. Whatever it may be the ionic hydride. So when it is dissolved in water, it will form hydroxide with the liberation of hydrogen gas at anode. That is one more important point. Name the gas liberated at anode during the hydrolysis or you can say electrolysis of this hydrides, ionic hydrides. So what is the answer for that one? They release hydrogen at anode. Okay, remember this one. Yes, next one. Next question. Okay, Calgon used as water softener is, you know that Calgon is nothing but sodium hexametaphosphate. Sodium hexametaphosphate. In the NCERT textbook, it has been given as Na6P6O18. Na6P6O18. Okay, so the answer for this one is the first one, that is Na2Na4. Right? So it is a PO3 6 time. It is a coordination compound. It is a complex compound where we can see that 2 sodium atoms are present outside the coordination sphere. Remaining will present inside the coordination sphere. Together, what you call this one as sodium hexametaphosphate. Commercially, that is also called as Calgon. So the answer for this one is the first option. Next question. That is they have given some chemical reaction, that is H2 plus CO plus R CH double bond CH2. That is nothing but alkene reacts with a mixture of H2 and CO to form a compound, that is nothing but an aldehyde, right? R CH2 CH2 CH2. What do you call for this one? So this reaction, here there is addition of both what? Hydrogen as well as formyl group. So this reaction is hydroformylation. That is option number 2, hydroformylation. It is nothing but the property of dihydrogen that has been given in the textbook. Direct reaction this is. So whenever the mixture of this hydrogen and carbon monoxide is made to react with the alkene, it leads to the formation of an aldehyde, right? So what is the answer for this one? Option 2, hydroformylation. Next one. Okay, so when same amount of zinc is treated separately with excess of dilute sulfuric acid and excess of sodium hydroxide, the ratio of volume of hydrogen evolved is, for this we have to write down the reaction, very simple they are. Once again, zinc on reaction with sulfuric acid forms what? Zinc sulfate with the liberation of dihydrogen gas. Similarly, one more they have given, reaction of sodium hydroxide, right? So here zinc, it is bivalent, that's why it reacts with 2 moles of sodium hydroxide, leads to the formation of a compound that is called as NaZnO2, sodium zincate, that is with the liberation of dihydrogen gas. So what the question is actually, so we have to find out the ratio of volume of hydrogen evolved. Okay, so both are separately made to react with excess of sodium, that is nothing but sulfuric acid, as well as sodium hydroxide. In one place it is made to react with sulfuric acid, in one place it is made to react with the sodium hydroxide, that is nothing but a base. So we have to find out the ratio of hydrogen gas which is formed, right? So it is 1:1. In both the cases, one molecule of hydrogen gas will be evolved. So the answer is the first option, 1:1. Understood this question? Yes. Next one. Yes. Chemical not useful in softening of hard water. It is a direct question. See, they have given calcium permutate, CaZ means calcium permutate, sodium hexametaphosphate, and then organic resin, slacrylamine. Slacrylamine means CaOH twice. Okay, that is also used in the what? Softening of hard water, and this one organic resin, that is also used. Similarly, sodium hexametaphosphate is also used. The first one, that is nothing but calcium permutate. How to read this one? Calcium permutate. In the process actually we are going to use sodium permutate, right? Sodium permutate. So it is not correct. It is the product form. Whenever you made to react the hard water containing calcium ions, they will be exchanged with this sodium, right? So then you are going to get what? In place of this, you are going, it is actually 2NaZ, so you are going to get CaZ2 plus Na will be replaced, Na will be exchanged, cationic exchange this is, right? So they ask us the chemical which is used in the softening of water, we cannot use this one, we can use this one. This is actually the permutate. This is the product which is exchanged with the cation of the hard water. Okay, so option 1 is the answer for that one. Next one. Yes, why does H plus ion always get associated with other atoms or other molecules? So the options are, yes, ionization enthalpy of hydrogen resembles that of alkali. Next one, so here you can have its reactivity is similar to halogen. Actually it is not correct. It resembles both alkali metals and halogens, yes, but the last option, loss of an electron from hydrogen atom results in the nucleus of very small size as compared to other atoms or ions due to small size. It says, yes, the question is why it cannot exist alone, H minus ion, or you can say, so whenever this, what is that, H plus, you can have proton, H plus. When you are going to get this H plus, when one electron is removed from the hydrogen atom, you are going to get H plus, right? It is having positive charge and it is very small in size because it has only one electron, that electron also we remove, right? So that's why, so it will always associated with other atoms or ions. You can have the example of this one, no? Yes, what is that? HCl, when it is dissolved in water, it will form into H3O plus Cl minus, but not H plus and Cl minus. What is this H3O plus? This is called as hydronium ion. As the size of this H plus is very small, it is highly unstable as it possesses the positive charge, it always preferred to associate it with other atoms or other ions. Okay, na? So option 4 is the answer for this one. We will move on to the next question. Yes, sulfur trioxide is dissolved in heavy water to form a compound X. The hybridization state of sulfur in X is, okay, you learn this one in case of chemical bonding, but reaction is there in the this hydrogen chapter. Let us write the reaction. So sulfur trioxide, whenever it is made to react with the deuterium oxide, or you can say the heavy water, what it will form? It will form D2SO4. D2SO4. That is our compound X. In the question, the compound X. Now we have to find out the hybrid state of sulfur in this. For that, if I write the structure, it is double bond O, here OD and then OD. So this is what your deuterium sulfate. Okay, deuterium dideuterio sulfuric acid, actually it is dideuterio sulfuric acid. So here the hybrid state of this one is what? sp3 hybrid, because it will form 4 hybrid orbitals. Is that clear? So hybrid state of this sulfur in case of this dideuterio sulfuric acid is sp3. That is the option number 2. Okay, understood this one? Move on to the next one. Yes, hydrogen cannot reduce hot cupric oxide, ferric oxide, hot stannous oxide or hot alumina, that is Al2O3. So the answer for this one is hot Al2O3. Whereas all other are there no remaining, they can be reduced by hydrogen, but this cannot be, because reduced by hydrogen means what? We have to remove this oxygen to form the aluminium, right? So because here hydrogen is acting as what? A reducing agent. That means to say it should get oxidized and reduce others, right? So Al2O3 should be converted into 2Al. It will not happen. Do you know why? Because this aluminium is having more affinity towards the oxygen than the hydrogen. So it will not allow the oxygen to, or it will not allow the hydrogen to replace this oxygen. So the answer is the fourth option, Al2 hot, Al2O3 is the answer for this one. Understood the reason why it cannot? Because aluminium is having more affinity towards oxygen than the hydrogen. Next one. Yes. When a molten ionic hydride is electrolyzed, okay, hydrogen is liberated at the cathode, hydrogen is liberated at the anode, there is no reaction, H minus ions produce migrate to the cathode. I already discussed this one, I think. Yes, that is nothing but ionic hydride. Sodium hydride, when it is ionized or electrolyzed, it liberates hydrogen at the anode. That is option number 2. I written the reaction also by taking the example of NaH. So second is the option, second is the answer for that one, right? Next question. Yes. In which of the following hydride law of constant composition does not hold good? You know, when we discuss about the different types of hydrides, so there are ionic hydrides, covalent hydrides and metallic hydrides, right? So out of these, sodium hydride is an ionic hydride, so that is the example for stoichiometric ionic hydride, magnesium hydride and lithium hydride. All these three are what? They are having a proper proportion of both the atoms present in that particular hydride, right? But if you take the fourth one, that is nothing but zirconium hydride, it is an example for interstitial hydride, right? So that is also called as what? Non-stoichiometric hydride. So where the proportion of both zirconium hydride and hydride is not in equal ratio. It is not in constant composition. Athwa, it will not obey the law of constant composition, right? So option 4. Next question. Yes. So next one. So the volume of oxygen obtained at STP when 6.8 gram of H2O2 undergoes decomposition. Okay, you have to calculate the volume of oxygen obtained when 6.8 gram of H2O2 undergo decomposition. Very simple calculation this is. For that you should know the reaction of this one. Decomposition means it will undergo decomposition to form what? Water plus oxygen, right? 2 to the 4, 4, 2 to the 4, 4. Okay. So here, what is the molar mass of this one? So it is 2 into 34. You know 34? This is 32, O2 is 32 plus 2, 34, 34 into 2, that is 68 gram, right? 68 gram produces how much oxygen? 1 mole of oxygen. O2 means 1 mole of oxygen. What is 1 mole of oxygen? 22.4 liters or dm cube you can write. What the question is? What is the volume of oxygen liberated when 6.8 gram of this hydrogen peroxide undergo decomposition, right? For 68 it is 22.4 means how much for 6.8, that you have to find out. How to find out? 6.8 into 22.4 divided by 68. If you do, so you are going to get 2.24. 2.24. So which is that option? That is 2.24 liters, right? So that is option 3 is the answer for this one. So understood? Very simple this is. Next one. Next one. So pH of water coming out of cation exchange resin is equal to 7 or greater than 7 or less than 7 or cannot be predicted. So here you have to see that it is a cation exchange resin. Cation exchange resin means which ion will be exchanged here? Say if the hard water contains calcium ions means you are adding to the resin means. So if it is RH, cationic exchange resin means we are going to represent this one as RH. So what happens here? So there is a replacement of this one, right? So CAR you are going to get CAR or CAR2 with the replacement of this H plus. H plus will be released into that water. Calcium ion will be trapped. Calcium ion will be trapped with the resin. What you are going to get here is nothing but what? Hydrogen ion. So if hydrogen ion released into the water, what happened to the pH? pH decreases because acidic strength increases here. pH decreases, acidic strength increases. Whenever there is a release of OH minus, say for example the same question is asked for the anion exchange resin means, so what happens here? There is a displacement of OH minus ion. So here there is a displacement of which ion? H plus ion. If H plus ions is released into the water, the acidic strength increases, whereas if you come to the pH decreases, pH will be less than 7. So the option 3 is the answer for this one. If you move on to the next question. Yes, what are X and Y? So what is that structure they have given? That is nothing but the formula, or you can say structure of water, right? So here you have to find out what are X and Y. So it is nothing but the angle, right? So what is that angle? 104.5 degree bent V shape structure, right? So and then what is this? This is X. And what is that Y? That is nothing but the dipole moment that can be expressed as 1.85 dBi. 1.85 dBi. So option 2 is the answer for that one. Why there is a variation of this angle? Because of the presence of lone pairs of electron on the oxygen atom that leads to the what? A repulsion between those two, and so the normal bond angle changes from 109 degree to 104.5 degree in case of water. So water, rather than having a tetrahedral structure, it is having a bent V-shaped structure with a bond angle of 104.5 degree and a dipole moment of 1.85 dBi. From that you come to know that water is a dipole molecule, okay, or water is a polar solvent. Next one. Yes, so it is a match the following type question. So you have to match the list 1 with the list 2 with the correct answers, okay. So heavy water, you know the formula, D2O, that is option C. Temporary hard water, that is mainly because of bicarbonates of magnesium and calcium, that is option. So for first one, option C. First one, option C. Second one, temporary hardness of water, it is option A. Option A, bicarbonates of calcium and magnesium, and then soft water. Okay, so soft water is no foreign ions in water, that is B. For third one it is B, and the last one, permanent hardness of water, that has been given there itself. So the fourth one, right, it is right, A, B, C and D. Fourth one D, where it is? So that is first one C, second one A, that is option number 4 is the answer for that one. First C, second A, 3 B and fourth D, right. Next question. Yes, it is based on the physical properties. The boiling point of water is exceptionally high. You know the reason? So that is, there is a covalent bond between hydrogen and oxygen. No. Water molecule is linear. That is also not the answer. So water molecule associate due to hydrogen bonding. Maybe water molecule is not linear, right? So the option 3 is the answer. Because of extensive hydrogen bonding, we can see that the boiling point of water is very high. That we count as the abnormal property of water, abnormal behavior of water, right? So why it is so high? Because of hydrogen bonding. Option 3. Next one. Next question. Yes. When an electric current is passed through an ionic hydride in molten state, this has been repeated again. So answer is option 1, hydrogen is liberated at anode. Next question. Yes. So it is a very simple question again. A given solution of H2O2 is 30 volume. Its concentration in terms of molarity. So in the beginning itself I have given the relationship between volume strength and molarity. Volume strength is equal to 11.2 into molarity. 11.2 into molarity. Okay. So what they have asked us here, its concentration in terms of molarity. What does molarity become? Molarity is equal to what? Volume strength divided by 11.2. What is the volume strength they have given? Yes, that is 30 divided by 11.2 if you do. So how much you are going to get? That will come around 2.68 molar. 2.68 molar, that is the option 2. So these are all the questions associated with the chapter hydrogen. I hope you all understood. So thank you.